Ever held an apple in your hand and felt its surface? You can feel how waxy and shiny it is. Have you ever wondered why certain fruits have such smooth skin? Let us find out in today's episode.
Hello everybody, I am Devabrata Goswami. Welcome to Organic Chemistry. Today we will study some very interesting compounds, that is hydrocarbons. In this episode we will talk about hydrocarbons. Then I will give you an overview of alkanes, which is a class of hydrocarbons. After this we will discuss isomerism in alkanes and preparation of alkanes. And finally, we will wind up our discussion with important questions in exam decoded. All of you must be familiar with cooking gas cylinders and the gas they contain, that is LPG. Compressed natural gas, CNG, is also a major automobile fuel. The other common fuels used are petrol, diesel and kerosene. Do you know what they have in common? All these are composed of hydrocarbons. As the name indicates, hydrocarbons are compounds of only carbon and hydrogen. These hydrocarbons are of two types, saturated and unsaturated. Hydrocarbons which contain carbon-carbon single bonds are said to be saturated, while hydrocarbons containing carbon-carbon multiple bonds are called unsaturated hydrocarbons. Recall that multiple bonds means double and triple bonds. Saturated hydrocarbons are known as alkanes. Unsaturated hydrocarbons are divided into two classes, alkenes, which contain carbon-carbon double bonds, and alkynes, which contain carbon-carbon triple bond. Remember, in the beginning of the episode, I talked about the shiny surface of an apple. Why is an apple waxy and shiny on the outside? This is because the shining layer on fruits such as apples consists of long chain alkanes. These carbon chains are usually between 20 to 30 carbon atoms in length and are made by plants from fatty acids. It is these long chain alkanes that form a firm layer of wax called cuticle. This protects the plant from water loss. We have a young caller with us who wants to clarify a doubt. Hello.
Hello sir, I'm Kriti. My question is, why are alkanes also called paraffins?
This is a nice question which can come in your exams for 1 mark. The word paraffins is derived from Latin words param meaning little and affins meaning affinity. This means little affinity or little reactivity. Alkanes are called paraffins because of their low reactivity. I hope that answers your question. But now it's my turn to ask one. And this is especially for the outer space fans. Where would you expect to find alkanes in the solar system? Yes, they are present in outer space. Alkanes, that is, mostly methane and ethane, form significant portion of the atmospheres of planets such as Jupiter, Saturn, Uranus and Neptune. In fact, Titan, a satellite of Saturn, contains methane gas. Also, a methane spewing volcano was spotted on Titan, and this volcanism is believed to be a significant source of the methane in the atmosphere. There also appears to be methane and ethane lakes near the north polar regions of Titan, as discovered by Cassini's radar imaging. And that's not all. Alkanes have also been detected in meteorites.
Methane not only forms the atmospheres of some planets, it also gives us energy. This simplest alkane has only one carbon atom and is the main component of natural gas.
Can you recall where you have heard the word natural gas earlier? It's CNG or compressed natural gas. So, when you see a CNG station next, remember it is mainly composed of methane gas. Methane is also found in coal mines. Being a highly combustible gas, it has caused several coal mine explosions.
Let us now see how alkanes are named. International Union of Pure and Applied Chemistry, or IUPAC, has given a set of rules to name organic compounds.
Take a look at this table. For simple straight chain alkanes, the name is written by writing the word root, which indicates the number of carbon atoms. Then ANE is written as a suffix after the word root, which indicates that it is an alkane. For example, methane is the alkane with one carbon atom. Here, meth is the word root and ane is the suffix. Ethane is the alkane with two carbon atoms. Here, eth is the word root and ane is the suffix.
Well, now it's time for a short break. But before going, here is a chance to exercise your gray cells. Tell me which two alkanes are found in liquefied petroleum gas. Don't know? Keep thinking. You can also log on to www.topperlearning.com for this and other questions and answers. See you after this short break. Welcome back. I am Deobata Goswami and you are watching Chemistry 11. Before the break, I asked you which two alkanes are found in liquefied petroleum gas. I hope you are ready with your answer. But now it's my turn to answer this. Propane and butane are the gases which are found in liquefied petroleum gas. Is there a general formula for alkanes? Yes, there is. The general formula for alkanes is CnH2n plus 2, where N stands for the number of carbon atoms and 2n plus 2 stands for the number of hydrogen atoms in the molecule. With this formula, we can derive the formula of any alkane.
For example, methane has only one carbon atom. Substituting 1 in the general formula, we get the formula of methane. It's CH4. Similarly, the formula of alkane with two carbon atoms is C2H6 and it's called ethane. You can do this for other alkanes as well. But what happens when you remove a hydrogen atom from an alkane? A group called an alkyl group is formed. So when we remove a hydrogen atom from methane, we get methyl group, which has the formula CH3. While we get ethyl group from ethane. The formula of ethyl group is C2H5.
Now, let us study a phenomenon with twists and turns. I mean isomerism. Recall that isomerism is the phenomenon of existence of two or more compounds which possess the same molecular formula but different properties. The type of isomerism which arises due to different structures is called structural isomerism. The manner in which the atoms are linked in structural isomers is different. Let's see what that means taking an example of alkanes having the molecular formula C4H10. Suppose I have 4 black balls which represent carbon atoms, and I have 10 white balls which represent hydrogen atoms. Now I know that carbon forms 4 single bonds and hydrogen forms 1 single bond. So let us try and form the structure of the molecule. The first arrangement possible is this, in which all carbon atoms are arranged as a single straight chain. Another arrangement is the one in which 3 carbon atoms are arranged in a straight chain and 1 carbon is present as a branch on the second carbon. So there are 2 arrangements possible for the same number of carbon and hydrogen atoms. So we conclude that for an alkane with a molecular formula C4H10, 2 structures are possible. This phenomenon of existence of compounds having the same molecular formula but different structures is called structural isomerism. Structural isomers, which differ in chain of carbon atoms, are known as chain isomers.
Now, if you look at the first 3 alkanes, methane, ethane and propane, they have only one structure.
The higher alkanes can have more than one structures. Butane, as we have seen earlier, has 2 isomers.
The first isomer is N-butane, in which the carbons are joined in a straight continuous chain. When the carbons are joined in a branched fashion, it is called isobutane. Though both N-butane and isobutane have the same molecular formula C4H10, the properties of these 2 compounds, that is N-butane and isobutane, are different. For example, boiling point of N-butane is 273 Kelvin, while that of isobutane is 261 Kelvin.
Can you tell me why N-butane and isobutane have different boiling points in spite of having the same molecular formula? Well, this is because N-butane and isobutane are structural isomers and differ in linking of carbon atoms. N-butane is a straight chain molecule and has a larger surface area. So, it will have stronger intermolecular forces. On the other hand, isobutane is a branch chain molecule and has a smaller surface area. Thus, it will have weaker intermolecular forces. So, N-butane has a boiling point of 273 Kelvin, while isobutane has a boiling point of 261 Kelvin. Now that we know what alkanes are, let's study how they are prepared.
Alkanes are prepared from unsaturated hydrocarbons, that is, alkenes and alkynes, by reacting them with hydrogen gas. This process is called hydrogenation. The reaction is carried out in the presence of finely divided catalysts like nickel, platinum or palladium. If platinum or palladium is used as a catalyst, the reaction takes place at room temperature. But if nickel is used as catalyst, the reaction takes place at a relatively higher temperature and pressure. Hydrogenation reaction of unsaturated hydrocarbons is carried out using nickel at a temperature of 523 to 573 Kelvin. Propene is reacted with hydrogen in the presence of platinum, palladium or nickel to form propane. Propane can also be prepared from propyne by reacting it with hydrogen in the presence of platinum, palladium or nickel.
Can you figure out the disadvantage of hydrogenation method? Think about it. Well, the disadvantage is that this method cannot be used for preparation of methane. This is because methane has one carbon, but in this, the starting reactant is either an alkene or an alkyne, which have at least 2 carbon atoms. Now, what is the method which can be used to prepare methane? The answer is decarboxylation reaction.
In decarboxylation reaction, a sodium salt of monocarboxylic acid is heated with soda lime at about 630 Kelvin. An alkane with 1 carbon less than the carboxylic acid is formed.
Please note that soda lime is a mixture of sodium hydroxide and calcium oxide in the ratio of 3:1.
This method is called decarboxylation reaction because a molecule of carbon dioxide is removed from the carboxylic acid. Alkanes can also be prepared from aqueous solution of sodium or potassium salt of carboxylic acid by electrolysis. Alkane containing even number of carbon atoms is formed at anode. This method is known as coal-based electrolytic method. This reaction is proposed to follow free radical mechanism. Let us study the mechanism by taking the example of sodium acetate. Firstly, aqueous solution of sodium salt of carboxylic acid, which here is sodium acetate, dissociates into its ions. At anode, oxidation takes place. Acetate ion loses electrons and forms acetate free radical. This acetate free radical formed loses carbon dioxide and forms methyl free radical. Methyl free radical combines with another methyl radical to form ethane. At cathode, hydrogen gas is liberated.
I hope you got that. If you need to make notes, just log on to www.topperlearning.com and get your concepts clear. It's now time for a short break, but don't go anywhere. Coming up on the other side of the break is Exam Decoded. Welcome back. This is Debabrata Goswami and you are watching Chemistry 11. We have been discussing alkanes and their preparation, and it's now time to put our learnings to the test. But before that, here is a quick recap for those who missed out some part of the lesson.
Alkanes are hydrocarbons containing carbon-carbon single bond. The general formula of alkanes is CnH2n plus 2, where N is the number of carbon atoms. Alkanes which have the same molecular formula but different structures, or the manner in which carbon atoms are linked, are called its structural isomers. Alkanes can be prepared by hydrogenation, decarboxylation or coal-based electrolytic method.
I hope that was clear, because now we are heading to the segment you have been waiting for, Exam Decoded. Welcome to Exam Decoded. Before I give you some important tips on today's episode, let's play our rapid fire round. The rules are really easy. I will ask you 5 questions. You have to answer each question in under 5 seconds. You will score 1 mark for each correct answer, and I will help you interpret your total with our special topper scorecard. So let's begin. Here is your first question. The reaction of propene with hydrogen gas in the presence of finely divided catalysts like nickel, platinum or palladium is called A. Hydration, B. Hydrogenation, C. Decarboxylation, D. Electrolysis. The answer is B. Hydrogenation. Second question. The name of the first alkane is A. Propane, B. Butane, C. Methane, D. Ethane. The answer is C. Methane, which has 1 carbon atom and the molecular formula is CH4. Next question. General formula of alkanes is CnH2n plus 2. True or false? The answer is it's true. Fourth question. Butane and isobutane are A. Chain isomers, B. Stereoisomers, C. Enantiomers, D. None of these. The answer is A. Chain isomers. As you know, N-butane and isobutane are the 2 chain isomers of butane. Now for the last question. Isomerism is the phenomenon of existence of 2 or more compounds possessing the same molecular formula but different properties. True or false? The answer is true. And now for the score, compare your total to our scorecard and see where you fit. If you have scored full marks, then you are a high flyer and can rest assured that your preparation is going well. If you have scored 4 or 3, then you are an achiever, with just a bit more revision of sample questions required. If you have scored less than 3, then you need help with the basic concepts of the topic. You can get this help on www.topperlearning.com. Now, let's have a look at the latest exam trends. This topic, alkanes, comes under the unit hydrocarbons. It has a weightage of 8 marks. So, this makes it a critical unit to focus on. The questions asked from this topic can be very short answer type questions for 1 mark and short answer type questions for 2 or 3 marks. These questions will typically test your knowledge ability. Now that you know that, you must also know how to score full marks in these questions. Let's see what your examiner expects you to write in your answers. What is the general formula of alkanes? Write the name and molecular formula of the alkane with 5 carbon atoms. This question can come for 3 marks in your exams. The general formula of alkanes is CnH2n plus 2, where N is the number of carbon atoms. This will fetch you 1 mark. Using this formula, we can write the formula of the alkane with 5 carbon atoms. The molecular formula will be CnH2n plus 2. Since N is equal to 5 here, the formula will be C5H12. Writing the correct formula will fetch you another 1 mark. To write the name, the word root of this alkane with 5 carbon atoms is pent and the suffix will be ane. So, the IUPAC name of the compound is pentane. The correct name will fetch you the last 1 mark. Well, that's all for today. I hope you have got a sense of what alkanes are and how you should tackle questions from this topic in your exams. But I will leave you with some food for thought. Which causes more greenhouse gas emissions? Rearing cattle or driving cars? Surprisingly, the answer is rearing cattle. Everyday ruminants like cows burp methane, which is a better greenhouse gas than carbon dioxide. Think about it, or you can log on to www.topperlearning.com for this and other answers. This is Debabrata saying goodbye. Till then, keep studying, keep thinking.